All right, so based on the last video, we have the equation y equals a sine b of x. And we've determined right now that a is just the amplitude. So the last thing we have to figure out is what this b value does. And so this actually directly relates back to an equation. B can actually be used to find the period. Now, don't get that confused. B is not exactly the period. We have to do a little bit of math to actually find the period, okay? So if we were to look at this problem, let's just cross this one out and only worry about the one. Let's look at y equals sine 1/3 of x. Below here, I have in black the original equation, which is just y equals the sine of x. We want to see what happens when I put that 1/3 in the middle there. So we're going to graph out y equals sine 1/3 of x. Well, almost everything stays the same. Okay, almost everything's going to stay the same. My max and my min are not going to change. What this changes is the actual period of the function. While this graph ends at 2 pi, my sine of 1/3 of x is not going to do that. So let's figure out where it's actually going to end. Let's see how long one period takes. Well, if I take this equation up here, and I take this 2 pi and divide it by 1/3, well, one of the things you have to remember is anytime we're dividing by a fraction, we skip, flip, multiply. So really this is going to turn into 2 pi because I skipped the top. I'm going to flip the bottom, 3/1, and turn that into multiplication. Well, because of that, my answer for this comes out to be 6 pi, which is the period for the new function. So the period of this is 6 pi. Well, that's kind of insane because that means from 0, my starting point, all the way to 6 pi is going to include both one max and one min. Well, now what we're going to do is start plotting some easy points. Well, if you notice in my original graph right here, if I go right directly in the middle of this graph, in between 0 and 2 pi, I have another point at 0. Well, I can actually apply this in this. If I go from 0 to 6 pi, directly in the middle is that 0 point, or 3 pi. Now, we could do the math to solve this. Basically, if you wanted to figure out the exact coordinates of where these are going to match up with, I could take my original pi value, which was 0, and divide it by 1/3 and get the same answer, 3 pi. Okay? If at pi you have an answer of 0, then if I do the same equation and if I divide out the 1/3, at 3 pi I also have a 0. Then from there I can continue this process. If you notice, I have a max at pi/2 for my original. Well, if I go to my new graph in red here, all I have to do is look for the middle portion. Well, in between 0 and 3 pi, the middle coordinate is just 3 pi/2. So if you notice, this graph got stretched out along that line. Same thing over here. If you look in the middle between 3 pi and 6 pi, it is 9 pi/2. So there's going to be my min, and it gets stretched out over here. So now, because of this, my period has become 6 pi. And if I use my box method all the way over, what it has done is it has stretched out the graph so it takes longer for that first rotation to occur. Okay? Now, this is kind of a simple process, right? The big equation that we have to remember here is this. 2 pi over b is going to give me my period. And from there, we can help kind of find a lot of different values. All right? Thank you for paying attention today. Thank you for listening. If you have any questions for me, please let me know. Send it on Google Classroom or Remind. On top of that, we will have a quizzes for today. Okay? We will be getting into cosine as well for next week, which is very similar to sine. So kind of keep these ideas in mind. And good luck. If you have any questions, please let me know. Thanks for watching.